Kavali. In the last class, we discussed about the fourth unit topics, that is superposition theorem. So that means in any linear network containing two or more elements, we have considered one source at n time and the remaining sources must be non-operated. That means one source will be, if there is a voltage source must be there, you have to short. If the current source must be there, you have to open. In this class, I discuss about the next theorem, that is reciprocity theorem. Reciprocity theorem. So what is reciprocity theorem? In any linear network consisting of a linear or bilateral impedances and active elements must be there, the ratio of voltage introduced in one loop to the current I in other loop is same as the ratio obtained if the positions of voltage and current are interchanged in the network. So that means if there is in any branch of the network, the current due to single source of voltage in the network is equal to the current through that branch in which the source was originally placed, when the source is again put in the branch in which the current was originally obtained. That means if any network, if the ratio of voltage V introduced in one loop and the current in the other loop is same as the ratio obtained if the positions of V and I are interchanged, is nothing but the reciprocity theorem. So in simple words, we can state that the reciprocity theorem, as when the places of voltage and current source in any network are interchanged, the amount of magnitude of current and voltage flowing in the circuit remains same. If the simple circuit must be there, the first here the voltage must be there. In the first branch, first loop, there is a voltage source must be there. The second loop, there is a current source must be there. So then you have to find out the voltage and the current, the ratio of voltage of the current. Then we have interchanged that. That means the first loop voltage source will be goes to the second loop, and you have to find out the first loop current. So then the ratio of V by I must be same. That is, then the reciprocity condition will be satisfied. So reciprocity theorem is in any linear network consisting of linear and bilateral impedances, the ratio of voltage introduced in one loop to the current I in other loop is same as the voltage ratio obtained in the positions of voltage and current are interchanged. Then the condition will be satisfied, reciprocity theorem. So reciprocity theorem, as voltage and current source in a network interchange, the amount or the magnitude of current and voltage flowing in the circuit remains the same. So we take a simple circuit. So here the reciprocity theorem is explained with the help of the circuit diagram as shown. So when you saw here the how many resistors must be there? 3, R1, R2, R3. Same resistance here also, R1, R2, R3. There is no change of that. But you have to understand here, there is in the first loop, the input will be the voltage. In the second, there is the current source, voltage source and the current source. So first we have to calculate the magnitude of the voltage by ratio of voltage by current. Then you have to interchange. That means the voltage source will be go to the second loop, and the current source will be come from the first loop. Then you have to find out the voltage by current magnitude. Then you get the same. Then these two must be equal. Then we satisfy the reciprocity theorem. So in the last there is the various resistances R1, R2, R3 is connected in the circuit diagram above with a voltage source V and a current source I. A voltage source V and current source I with the resistances of R1, R2 and R3. It is clear from the figure above that the voltage source and the current source are interchanged for solving the network with the help of reciprocity theorem. So, in the first there is the voltage source and the current source. By acting it will be the condition will be satisfied or then you have to interchange the voltage placed to current and current placed to voltage with the help of this reciprocity theorem. The limitations of this theorem is that it is applicable only to single source networks. It is applicable only if there is single source must be there, then it will be applicable, and not in the multi-source networks. The network where reciprocity theorem is applied should be linear and consists of resistor, inductors, capacitor and coupled circuits. The circuit should not have any time varying elements. So when the circuit must be there, the circuit will not have any time varying elements. These are the limitations. So what you have to follow? Firstly, select the branches between. So first you have to select what are the branches must be there, and the current in the branch is obtained using any conventional network analysis. Then you have to find out the current. Then the voltage source is interchanged between the branch which is selected. So first select the branch between which you have to be find out. Then in the second, so we have to find out the current in that branch, and then next one you have to interchange the voltage sources. Then fourth one, the current in the branch where the voltage source was existing earlier is calculated, and then you have to calculate the current in that branch. Now it is seen that the current obtained in the previous connection, that is in step 2, and the current which is calculated when the source is interchanged, that is in step 4, are identical to each other. So first, whatever the circuit must be there, you have to calculate the current, and then next thing you have to interchange the source. So whenever you have to interchange the source, then what happened? Then you have to find out the current. Then last you have to observe that whatever the first step you have to done, the same will be obtained, and the both are in, when there is interchange must be obtained, interchange will be there, the both will be same. Then we have to prove this reciprocity theorem. So I take a simple problem here. Here a single source, that is 45 volts, and 4 resistance must be there. One is 12 ohms, another one is 6 ohms, and third one is 2 ohms, and fourth one is 4 ohms. So I want to find out the current here. So the voltage source and the current. So now first, when you have to find out the current of this 4 ohm resistor, then you go to the first you have to find out the equivalent resistances. So how you find the equivalent resistance? So whatever the current flowing here the current will be divided. So then the same current will be going to 4 ohms. So 2 plus 4, it is 6. So 6 is parallel to 6. Okay, and this complete equation will be series to 12. So RTH is equal to 2 plus 4. It is parallel to 6, and this complete equation will be series to 12. So we get how much? 15 ohms. 2 plus 4, 6. Parallel means product by sum. 6 into 6 by 6 plus 6. 6 into 6, 36 by 6 plus 6, 12. So 12 threes. So 3 plus 12, there is 15 ohms. So, and what is the total current? Total current is equal to voltage by RTH. Total voltage by total resistance, that is 45 by 15, that is 3 amps. So I want current at 4 ohm resistor. So by 4 ohm or 2 ohm, because whatever the current flowing here, the same will be here, because two are in series. So according to the current division rule, I have to find total current into what is the opposite resistance of this 4? 6 by total resistance. 6 plus 2 plus 4, 12. So 3 into our total current into opposite resistance 6 by 12, that is 1.5 amps. 1.5 amps. This is as it is, what else the circuit will be there, I have to find out the current. Now, since now we have to interchange E and I. Now we have to interchange. So, since I is pointed downwards in the given problem, so the positive terminal placed downwards when we interchanged. Because here, generally here, this is positive and this is negative. But whatever the I you have to find out, that will be in the downward. So, here the battery will be, this is positive, this is negative. Since E positive terminal points upwards and given problem, the current I also points upwards in above diagram where it will be interchange. Here he will be upwards current, so I put here, and downwards it is downwards, I put here. Now I want to find out the current here. So first, when you have to find out the current, first you have to find out the total resistance. So from this, from here, the current will be divided. So 12 into 6 by 12 plus 6 plus 2 plus 4. So we get 10 ohms. So total current is equal to total voltage by total resistance, that is 4.5. By using current division rule, 4.5, that is total current into opposite resistance, that is opposite resistance of 12 is 6 by 6 plus 12. So we get 1.5 ohms. So here the current will be 1.5 ohms. Here the current will be 1.5 ohms. Since in both cases current are equal, so reciprocity theorem is verified. If it will be the not equal, it does not satisfy the reciprocity theorem. Okay, next thing. Next problem, reciprocity theorem. For the given network as shown in the figure, reciprocity theorem satisfied or not. So first they have given figure here. So you want to find the current at 24 kilo ohms. Same thing by using the equivalent resistance. So now the current is coming here and it will be divided in 3 parts. So this current 4 kilo ohms will be same to 20 kilo ohms. So 4 plus 20, that is 24. 24 is parallel to 24. Okay, and this will be parallel to again this 24. So 1 by 24 plus 1 by 24 plus 1 by 24. So total we get the 24 by 3 plus these 3 part will be series into 8 ohms. So 8 plus 24. So total current is equal to total voltage by total resistance. We get the 1.5 milliamps. But I want the current of this. So I is equal to, what is the total current into that opposite by total resistance. So we get how much? 0.5 milliamps. Next, we have to interchange this source. So when you have to interchange, I put the voltage source here and I want to find out the current here. Then the same figure will be redraw here, 8, here 24 and 24. So 24, it is series with the 24 because 20 plus 24, that is 20 plus 4, that is equal to 24 kilo ohms. So 24 kilo ohms, 24 kilo ohms and the voltage source is series with the 24 kilo ohms. So now I want to find out the current at 8 ohm resistor. So these three must be parallel. So we get the total current by this resistance, we get 0.83. So from that we have, according to this rule, I have to find out the 8 kilo ohms current, then the current will be 0.5 milliamps. So in the first also it will be 0.5 milliamps and the second condition also here it will be 0.5 milliamps. So we can conclude that this they will be satisfied. So we have to tell that for when there is the ratio of the voltage at the one loop and the current at the second loop, when you have to interchange the positions of this voltage and the current, then the values must be same, identical. Then the reciprocity theorem will be satisfied. This is about reciprocity theorem. Next we have go to the Thevinin's theorem. Thevinin's theorem. So what is Thevinin's theorem? Thevinin's theorem states that any two-terminal linear circuit containing a large number of voltage or current sources and resistor can be replaced by a single equivalent circuit containing single voltage source in series, single resistance. Thevinin's theorem states that in any linear network containing two or more voltage or current sources or resistances are there, it can be replaced. So any number of sources must be there or any number of resistance must be there. It can be replaced by a single voltage source in series with the single resistance. Single voltage source in series with the single resistance. This is a Thevinin's statement. So Thevinin's equivalent circuit resembles a practical voltage source, hence it has voltage source in series with the resistor. Generally for voltage source, resistor will be series, for current source the resistor will be parallel. So the voltage source present in the Thevinin's equivalent circuit is called as Thevinin's equivalent voltage or simply Thevinin's voltage VTH. So when you have to represent in the form of a single voltage source in single resistance, the single voltage source is represented by VTH. The voltage source present in the Thevinin's equivalent circuit is called as Thevinin's equivalent voltage or simply Thevinin's voltage VTH. The resistor present in the Thevinin's equivalent circuit is called as Thevinin's equivalent resistance or simply Thevinin's resistance. It is mentioned as RTH. So if the Thevinin's circuit, any number of voltage sources or current sources or resistance must be there. We have to replace it in single voltage, that is VTH, in series with the single resistor RTH. So how we have to solve this Thevinin's? So first follow these steps in order to find the Thevinin's equivalent circuit. When only the sources of independent type, if only the independent type are there, then you have to follow these steps. Step 1. Consider the circuit diagram by opening the terminals with respect to of which the Thevinin's equivalent circuit is to be found. So first you have to consider the circuit and by opening the terminals for in which part we have to finding that for that part first you have to open that. For finding the VTH, first that part will be open. Step 2. Thevinin's voltage VTH across the open terminals of the, so we put there VTH is there. So you have to find out where you have to find out the value. For first that part will be open. Then you have to put there VTH. Step 3. Find Thevinin's resistor RTH across open terminals of the above circuit by eliminating independent sources present in them. And for finding the RTH, what we do is for the complete circuit, First, whatever the open will be there, just you have to open that, and remaining whatever the independent sources must be there, that is voltage sources or current sources must be there. When there is voltage source, you have to put short. When there is current source must be there, you have to put open, and then you have to find out the Thevenin's resistance. Then draw the Thevenin's equivalent circuit by connecting Thevenin's voltage VTH in series with the Thevenin resistance RES. So first step, consider the where we have to consider the circuit diagram by opening the terminals where you have to find out the Thevenin's voltage, and then you have to find out the Thevenin's voltage for there. And for finding the Thevenin's resistance, first you have to whatever the open must be there, just you leave it that open, and then whatever the remaining sources must be there, either it be voltage or current source must be there, then all voltage sources will be short and current source will be open. Then you have to find out the VTH and RTH. Now we find the response in an element that lies in the right side of the Thevenin's equivalent circuit. So find the current flowing through the 20 ohm resistor by first finding a Thevenin's equivalent circuit to left terminals of AB. So at 20 ohm resistor, you have to find out the Thevenin's equivalent circuit. So for this circuit, I want to find out VTH and RTH. So for finding the VTH, you have to open this 20 ohm resistor. For finding the RTH, just you have to left this open, and current source must be open and voltage source must be short. So now go step 1. So in order to find the Thevenin's equivalent circuit to the left side of terminals AB, we should remove the 20 ohm resistor from the network. First you have to remove the wherever you have to find. Suppose they ask that 10 ohms, just you have to remove this. They ask that 5 ohms, just you have to remove. So wherever they have to ask, you just remove that. Or simply already they have to open that and they have find out the Thevenin's voltage across AB. So already it will be open. Just you have to find out Thevenin's voltage across, which means only you have to find out VTH and RTH. But here they ask the Thevenin's equivalent circuit with respect to find out the current at 20 ohm resistor. So first AB, we should remove the 20 ohm resistor from the network by opening the terminals AB. The modified circuit diagram is shown in the following figure. This is the modified circuit diagram. Next, step 2. Calculate the Thevenin's voltage VTH. There is only one principal node. So here, whatever either it will be the nodal analysis, or generally when you get upon the something the circuit resistors you have to find, that will be also we have there, but taking simple nodal analysis is there, and then you have to find the node voltage V1 of Thevenin's voltage VTH are labeled in the above figure. Here V1 is the voltage from node 1 with respect to ground, and VTH is the voltage across 4 amp current source. So when you have to find out the voltage of here, then you have to find out the voltage of this here, then you get the voltage across any resistor. If you have to find out at voltage of one element, then it will be parallel. If another element is there, then you have to voltage of that element, then this must be same, both are same. So what we do, so the node equation V1 minus, how we write on the node equation, algebraic sum of the currents is equal to 0. V1 minus 20 by 5, V1 by 10. Here V1 by 10, and this is the already current source must be there. So V1 by 10 minus 4, because for this algebraic sum of the currents must be there. These 4 amps will not go to the VTH side. This 4 amps comes to the 10 ohms. So we have to simply say that 4 amps is minus 4. We see is equal to 0. So 2V1 minus 40 plus V1 minus 40 by 10 is equal to 0. So 3V1 minus 80 equal to 0. V1 is equal to 80 by 3. So voltage across series branch 10 ohm resistor is V10 ohm is equal to minus 4 and into 10 is equal to minus 40. Why I am taking this means, so if I want the voltage here, this is the current source. So I want the voltages for this loop, that means 10 ohms and 10 ohms, the same voltage will be found here. So for that I am taking the KVL in this equation, then it is V10 is equal to minus 40. So substituting the values of V1 and V10 in the above equation, we get 80 by 3 minus V1 is 80 by 3 minus 40 minus 40 minus VTH is equal to 0. So why I am writing this, the KVL equation for this. What is V1 by 10? What is the V1 value? Already we get. And here what is the 10 ohm resistor? The voltage will be, what is the voltage here? V1 80 by 30 minus, how much voltage will be? Minus 40 minus VTH is equal to 0. So VTH is equal to 80 plus 120 by 3 is equal to 200 by 3 voltage. This is the Thevenin's voltage VTH is equal to 1. And next, calculate the Thevenin's resistance RTH. Now we have to calculate the resistance. So short circuit the voltage source and open circuit the current source, because whatever the sources, independent sources must be there, just you have to, if voltage source must be there, you have to short. If current source must be there, you have to open. So in this, in the circuit diagram, we have one current source and one voltage source. So current source will be open and voltage source will be short. So to calculate the Thevenin's resistance, so RTH across here, then you have to take the direction from this open side. So it will be entering here and the current will be, is assume one source, current source must be there. The current will be entering here and it will be divided here. So 5 is parallel to 10 and it will be series to 10. 5 into 10 by 5 plus 10 by 5 into 10 by 5 plus 10 plus 10, that is equal to 40 by 3. Therefore, Thevenin's resistance RTH is equal to 40 by 3. So if there is only if they ask the Thevenin's resistance, just you equivalent circuit is 1200 by 3 VTH and RTH is 40 by 3. But they ask the find the current across 20 ohm resistor. So for that what you do is VTH, RTH already you have to find. Just you put series 20 ohm resistances. Then the Thevenin's equivalent circuit is placed to the left of the terminals A and B in the given circuit. This circuit diagram is shown in the following figure. The current flowing through the 20 ohm resistor can be found by substituting the values of VTH, RTH and R in the following. So how you find out the current? Current is I is equal to V by R. So generally I is equal to VTH by RTH plus RL, because RTH and RL are in series. So 200 by 3 by 40 by 3 plus 20. So the current will be 2 amps. Therefore, the current flowing through the 20 ohm resistor is 2 amps. If suppose there is the circuit will be already open, then you have to find out the Thevenin's equivalent circuit. Then simply you get VTH and RTH. If it will be there is a resistor is there, then you have to find out the current. In the last step, when you have to find out the VTH and RTH, then you have to put the resistor there and then you have to find out I is equal to VTH by RTH plus RL. Then you get the current will be 2 amps. So if if it will be independent sources must be there. If suppose there is the both independent and dependent type will be there. So then you have to follow this steps. So what you consider the circuit diagram by opening the terminal with respect to which Thevenin. Same thing. In the first step, for method 1 also we have to done whatever you have to find out, wherever you have to find out, just you have to open. Next, step 2. Find Thevenin's voltage VTH across the open terminal. Here also you have to find out the VTH across open terminals. Next, step 3. Find the short circuit current ISC by shorting the two open terminals of the above circuit. Here just what you have to done means, first you have to open and then find out the VTH there and find the short circuit current there. Whatever, wherever you have to open, then you have to short there and find out the current there if there is both independent, if the circuit have both independent and dependent source are there, then only we have to do here. And find Thevenin's resistance RTH by using the following figure. So now you have to find out RTH is equal to VTH by ISC, that is short circuit current. Because in there RTH, how you find out the RTH? Just you have to independent sources must be there. Just you have to voltage source must be open short circuit and current source must be open circuit, and then you have to find out RTH. But here we have to find out RTH. Then wherever we have to open that, there we have to short and you have to find out short circuit current. Then RTH is equal to VTH by ISC. So draw the Thevenin's equivalent circuit by connecting Thevenin's voltage VTH in series with the Thevenin's resistor RTH. So this is about the Thevenin's circuit. So there is the reciprocity theorem and Thevenin's theorem. For reciprocity theorem, in the one loop there is voltage source, other loop there is the current. So when you have to interchange the voltage and the current, the magnitude must be same, then it is called reciprocity theorem. Thevenin's theorem means if there is a number of voltage sources, current sources or resistors must be there, you have to replace it a single voltage source VTH with single resistance RTH is called as Thevenin's theorem. This is about this class. Thank you.